Okay, good morning. Welcome to
FamilyMath number 283.
FamilyMath 283. So we just watched the Vi Hart video about pi equaling 4. And so what she did is she took a circle of diameter 1 and put a square around it.
Yeah, I think it was a circle of radius 1.
Okay, we can do it with a circle of radius 1.
Because then the circumference would be pi if it were diameter 1.
Okay, so I think the diameter was 1. So how long are the sides of the square?
Well, they would be 1, 2.
They would be 1. So what's the perimeter of the square?
This is 4.
Perimeter. And what's the circumference of the circle?
Pi.
How come?
Because it's 2 pi r, or pi times the diameter.
Alright. Okay. And how did she demonstrate that pi was 4?
Well,
I think she brought
she
in...
should have folded in the corners.
Okay, so let's fold in this corner here, like she did, ding, 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 over like that. Why doesn't that change the length of the perimeter?
Because you're just flipping it around. You're making this little square here,
Okay,
and you're moving these to here.
alright, do you understand that?
Yeah.
That going this distance, starting, like if you're walking around, maybe you would start here, walk around, walk around, walk around. When you get to here, going over and up that part of the square
Yeah.
is the same as going over, up and over that part of the square. Okay, does that make sense?
Yep.
So I'm just going to do it down on this one corner here. I don't know how carefully I can erase.
Then you fold in these two corners.
So you can imagine we do this on all the corners. Then we fold in these corners down here.
And that stays the same.
Yeah. So the perimeter stays the same there.
So,
And you keep folding in and in and in.
yeah.
And so what does the perimeter, when I do these infinite number of fold-ins,
It's still 4.
it's still 4. But what does it also seem to be?
A circle of diameter 1.
Of diameter 1. So 4 seems to equal
Pi.
pi.
And we know that's not right.
How do we know?
Because we know pi is 3.141.
Okay. What do you think's going on?
Maybe there's some area where we messed up somewhere.
Well, it seems like the only real important step was this fold in and making sure the perimeter stayed the same.
And it seems like it did stay the
As
same.
long as we make those squares every time.
Well, I think how Vi Hart put it was, it's not quite a flat line. You have infinitely many of these little peaks. Like you have that all along the surface of the circle.
Interesting.
But what if you do it infinitely?
Yeah,
It's
then
infinitely small. One of those is infinitely small.
That means it's 0.
yeah. Pretty strange, huh?
Yeah.
So something's going on here because we're pretty sure pi is not equal 4.
Yeah.
Right? In fact, we've even done a project where we took a circle and unrolled it, a frisbee or something like that.
Yeah.
And unrolled it, and we saw that it was a little bit more than 3
Yeah.
times around. So we're going to study a really fun shape today that's sort of like this, where we're going to see the same kind of surprising property happen when we have these infinite zigzags.
Alright.
And it's actually pretty cool. I saw it in a book this weekend. So I want to show you. The shape. Then we're going to build it out of Zone Tool. And then we're going to play with some things that I 3D printed, okay?
Okay.
All right, here we go.